In this video, we are going to see two-phase method. Before we see the problem, let us see the basic points. The first one is minimization type of objective function. See, in two-phase method, whatever may be the type of objective function in the original problem, only the minimization type of objective function is used in the two-phase method. If we get any maximization problem, just convert the maximization into minimization by changing the sign. Look at the second point, constraints. For greater than or equal to or equal type constraints, just subtract slack variable and add artificial variable, that is minus S1 plus A1. Okay, so for lesser than or equal to type constraints, just add slack variable only. Here we need not introduce any artificial variable. So this is the procedure regarding constraints which involves greater than or equal to and lesser than or equal to. The next point is it has two phases, phase 1 and phase 2. Okay, for phase 1, we are going to follow the same algorithm which we applied for simplex method, but with the revised objective function. Okay, so initially we have to prepare the initial simplex table for phase 1 and apply the usual simplex method till the optimality is reached. Okay, at the end of the phase 1, check whether the objective function value is 0 in the optimal table. If yes, go to phase 2, or else just conclude that this problem does not have any optimal solution. Okay, in phase 2, after finding the optimal table, from the optimal table, you have to proceed phase 2 by replacing the original value of objective function. Okay, let us see in detail along with the simple problem. Look at the problem, two-phase method. So minimization z is equal to 10x1 plus 6x2 plus 2x3. Okay, here we have got minimization problem. If we get maximization problem, the first step is we need to convert maximization into minimization by changing the sign. But here we need not worry about that because we have got minimization problem. Look at the constraints. Subject to the first constraint is minus x1 plus x2 plus x3 greater than or equal to 1. Next one, 3x1 plus x2 minus x3 greater than or equal to 2. x1, x2 and x3 greater than or equal to 0. Look at the second point, constraints. For greater than or equal to or equal type constraints, just subtract slack variable and add artificial variable, that is minus S1 plus A1. Okay, so for lesser than or equal to type constraints, just add slack variable only. Here we need not introduce any artificial variable. So this is the procedure regarding constraints which involves greater than or equal to and lesser than or equal to. Here we have got greater than or equal to. So we need to subtract slack variable and add artificial variable in the first constraint as well as for the second constraint. Now I am going to form the canonical form of the given problem. First step, framing the canonical form. So minimization z is equal to 10x1 plus 6x2 plus 2x3 subject to first constraint minus x1 plus x2 plus x3. Here we have got greater than or equal to. So subtract slack variable and add artificial variable is equal to 1. Second constraint 3x1 plus x2 minus x3. Subtract slack variable and add artificial variable is equal to 2. And x1, x2, x3, s1, s2, a1 and a2 greater than or equal to 0. Now we have to add the values in the objective function. The objective function is 10x1 plus 6x2 plus 2x3. No, just add 0s1 plus 0s2 plus a1 plus a2. So here we have got two slack variable. No, for slack variable we have to give 0 value plus 0s1 plus 0s2. For artificial variable value is 1, that is A1 plus A2. So this is the procedure to frame the canonical form of given problem. The next step is just copy the values as it is. That is the first constraint and second constraints must be as it is. Take the value as it is, and when we take the objective function, take only artificial variable, that is A1 plus A2. Just leave all other values. This is called as a revised objective function. Minimization z is equal to A1 plus A2 subject to, take the constraints 1 and 2 as it is, minus x1 plus x2 plus x3 minus s1 plus a1 is equal to 1. Second constraint, 3x1 plus x2 minus x3 minus s2 plus a2 is equal to 2, and x1 comma x2 comma x3 comma s1 comma s2 comma a1 and a2 greater than or equal to 0. With this information, we can start initial simplex table for phase 1. See the initial table. This is the format of initial simplex table format. That is Cj value, basic variables and cost of the basic variables, solution. Okay, so first we have to write the basic variables x1, x2, x3, s1, s2, a1 and a2. x1, x2, x3, s1, s2, a1 and a2. Values of the basic variables. For Cj, we have to take 0 for all the values except artificial variables. Look at the revised objective function. Here we have only artificial variables a1 and a2. So assign 1 for a1, a2, and for other variables put 0. So x1 0, x2 also 0, x3 0, s1 0, s2 also 0. For a1, a2 1, 1. Now frame the initial table for two constraints. For the first constraint, basic variable is a1. Okay, a1 value is 1. Okay, second one is a2. Right, a2 value also 1. Now fill all these values. See the first constraint, minus x1. No, so minus 1 plus x2. Put 1 plus x3. 1 minus s1. So minus 1. No s2. No, so 0. a1 value 1. No a2. So 0 is equal to solution 1. In the second constraint, 3x1. So x1 value is 3, x2 value is 1, x3 value minus 1, s1 value 0, s2. So minus 1, no a1. So 0, a2 value is 1 is equal to solution 2. Okay, now we have to find the zj value. In order to find out the zj, just multiply the cost with each and every element and add the second value to find out zj. Let me show the calculation. For the first one, 1 into minus 1 plus 1 into 3 is equal to plus 2. For the second value, 1 into 1 plus 1 into 1 is equal to 2. In the same way, we need to find zj value for each and every element. x1 2, for x2 also 2, for x3 0, for s1 minus 1, for s2 also minus 1, for a1 1, for a2 1. Solution is 3. Okay, after finding zj value, now we need to find cj minus zj values. Cj minus zj. Okay, cj value is 0. So 0 minus 2 minus 2. 0 minus 2 minus 2. 0 minus 0 0. 0 minus minus 1 is equal to plus 1. 0 minus minus 1 is equal to plus 1. 1 minus 1 is equal to 0. 1 minus 1 is equal to 0. So we have got cj minus zj value. After finding Cj minus Zj values, just check the optimality condition. For minimization problem, the optimality condition is all the Cj minus Zj value must be greater than or equal to 0, which means we need to get 0 or positive value. Look at the Cj minus Zj values. Here we have got two negative values. So we didn't reach the optimality. So we have to proceed further until we reach the optimality. Okay, in order to proceed further, we need to find the key row and key column and key element. Okay, in order to find out the key column, select the most negative. But here we have got tie, that is minus 2 for x1 and minus 2 for x2. So we can select any one, either x1 or x2 randomly. So now I am taking x1 as a key column. Okay, so this will be the key column, and after finding the key column, this will be the key column. Okay, after finding the key column, we need to find the key row. So in order to find the key row, we have to select the most positive. So in the solution column, we have got positive values. No. So which one is most positive? 1 or 2? 2 is the most positive. So this is the key row. So A2 is the key row and x1 is the key column and 3 is the key element. So now x1 is the entering variable and A2 is the leaving variable. So after finding the key row, key column and key element, now we can proceed further. Now we have to prepare first iteration. Okay, in the first iteration, just write the basic variables. x1, s1, s2, a1. In the first iteration, write all the basic variables except A2. Why? Because A2 is the leaving variable. Okay, you need not put separate column for leaving variable. Now write the value for Cj. Look at the initial table. Cj values are for x1 0, x2 0, x3 0, s1 0, s2 0, a1 1. You need not put a2. Why? Because a2 is the leaving variable. x1 0, x2 0, x3 0, s1 0, s2 0 and a1 1. See, in the initial table, the first one is row 1. Second one is row 2. Now we have to write the row 3. For row 3, instead of A2, we need to write x1. x1 is the entering variable. No. So this will be row 3. x1 is the entering variable. So entering variable value is 0. Put 0. Okay, in the x1, we need to find the new value. Okay, in order to find out the new value, just see the old value divided by key element. For the first value, the key value is 3 and old value also 3. So the answer is 3 divided by 3 is equal to 1. For the next value, 1 divided by 3, 1 by 3. See the next value, minus 1 divided by 3 is equal to minus 1 by 3. Next value, 0 divided by 3, 0. Next one, minus 1 divided by 3, minus 1 by 3. Next one, 0 divided by 3, 0. For solution, 2 divided by 3, 2 by 3. For solution, 2 by 3. Okay, now we have got the new value for row 3. So the entering variable is x1. x1 coefficient value is 0 and we have got the new value with the help of the formula. The formula is old value divided by key element. Now we have to find the row 4 values. Row 4 is, look at the previous one. A1 is there, no? So write A1. A1 value is 1. So you can write as it is. A1 coefficient value is 1. And now we need to find the new value. So in order to find out new value for row 4, we need to apply a simple formula. The formula is old value minus key column value into row 3 value. Look at the calculation. For row 4, the first one is minus 1. Old value is minus 1 minus key column value. This is the key column, no. So key column also minus 1 into row 3 value. Row 3 value is 1. See the calculation. Old value is minus 1 minus key column value, again same thing, minus 1 into row 3 value is 1. The answer is minus 1 plus 1 is equal to 0. Answer is 0. For the next value, the old value is 1 minus key column value is minus 1 into row 3 value. Row 3 value is 1 by 3. The old value is 1 minus key column value minus 1 into row 3 value is 1 by 3. The answer is 1 plus 1 by 3 is equal to 4 by 3. 4 by 3. In the same way, we need to find the new value for x3, s1, s2, a1 and solution. 2 by 3 minus 1 minus 1 by 3, 1, 5 by 3. Now we need to find Zj values. Zj value is, for the first one, 0 into 1 plus 1 into 0. You will get 0. For the next value, 0 into 1 by 3, 0 plus 1 into 4 by 3, 4 by 3. Next one, 0 into minus 1 by 3, 0 plus 1 into 2 by 3, 2 by 3. Next value, 0 into 0, 0 plus 1 into minus 1, minus 1. Next one, 0 into minus 1 by 3, 0 plus 1 into minus 1 by 3, minus 1 by 3. Next one, 0 into 0, 0 plus 1 into 1, 1. So after finding Zj value, now we need to find Cj minus Zj values. Cj minus Zj. Cj 0, Zj 0. So 0 minus 0 is equal to 0. Next one, 0 minus 4 by 3 minus 4 by 3. Next value, 0 minus 2 by 3 minus 2 by 3. Next one, 0 minus minus 1 is equal to plus 1. Next one, 0 minus minus 1 by 3 is equal to plus 1 by 3. Next one, 1 minus 1 is equal to 0. Now we have got the Cj minus Zj values. Now again check the optimality condition. For minimization problem, the optimality condition is all the Cj minus Zj must be greater than or equal to 0, which means we have to get either 0 or positive values. But here we have got negative values. So we didn't reach the optimality. We need to move further. So in order to move to next iteration, we need to find the key row, key column and key element. In order to find out the key column, we have to select the most negative. So which one is most negative? Minus 4 by 3 or minus 2 by 3. So which one is most negative? Minus 4 by 3 is the most negative value. So this will be the key column. So x2 is the key column. Now we have to find out the key row. In order to find out the key row, select the most positive. In the solution column, we have two values now. Which one is most positive? 2 by 3 or 5 by 3. So 5 by 3 is the most positive value. So this will be the key row. A1 is the key row, x2 is the key column and 4 by 3 is the key element. Now we have to prepare second iteration. In the second iteration, x2 will be the entering variable and a1 will be the leaving variable. So instead of a1, we have to enter x2. x2 value is 0. Okay, so x2 is the entering variable and a1 is the leaving variable. Now we can proceed iteration 2. Iteration 2, basic variables are x1, x2, x3, s1 and s2. We need not write a1 because a1 is the leaving variable. No. So we need not write a1 again. coefficient for these basic variables x1 0, x2 also 0, x3 0, s1 0 and s2 also 0. In the second iteration, we need to find the new values for row 5 and row 6. For row 5, look at the previous iteration. x2 will be the entering variable and a1 will be the leaving variable. So instead of a1, we need to write x2 here. So x2 coefficient value is 0. So x2 coefficient value is 0. Okay, so in order to find out row 5, look at the previous iteration. So the formula is old value divided by key element. So 0 divided by 4 by 3. For second value, 4 by 3 divided by 4 by 3. For x3, 2 by 3 divided by 4 by 3. For s1, minus 1 divided by 4 by 3. For s2, minus 1 by 3 divided by 4 by 3. So the new value is for x1, 0. For x2, 1. For x3, 1 by 2. For s1, minus 3 by 4. For s2, minus 1 by 4. For solution, 5 by 4. Okay, now we have to find out row 6. For row 6, there is a simple formula. So as we did in the previous iteration, you can follow the same procedure. Okay, so x1 value is 0. For the new value, the formula is old value minus key column value into row 5 value. See the first one. The old value is 1 minus key column value is 1 by 3 into new row value is 0. The answer is 1. For x2, old value is 1 by 3 minus key column value again 1 by 3 into new value is 1. The answer is 0. For the third one, old value minus 1 by 3 minus key column value 1 by 3 into new value 1 by 2. The answer is minus 1 by 2. For S1, old value is 0 minus key column value 1 by 3 into new row value minus 3 by 4 is equal to 1 by 4. For S2, the old value is minus 1 by 3 minus key column value is 1 by 3 into row 5 value is minus 1 by 4. The answer is minus 1 by 4. For solution, the old value is 2 by 3 minus key column value is 1 by 3 into row 5 value is 5 by 4. The answer is 1 by 4. Now we have to find Zj value. Okay, for Zj value, 0 into 0 plus 0 into 1 will get 0. For second one, 0 into 1, 0 plus 0 into 0, 0. The answer is 0. For x3, 0 into 1 by 2, 0 plus 0 into minus 1 by 2, 0. For s1, 0 into minus 3 by 4, 0 plus 0 into 1 by 4, 0. The answer is 0. For s2, 0 into minus 1 by 4, 0 plus 0 into minus 1 by 4, 0. So the answer is 0. So now we have got Zj values. Now we need to find Cj minus Zj values. Cj minus Zj value 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0. See, after finding Cj minus Zj value, just check the optimality condition. For minimization problem, the optimality condition is all the Cj minus Zj values must be greater than or equal to 0. So here we have got zeros. So we have reached the optimality. So after reaching the optimality, just check the important point as I said earlier. See the last point. At the end of phase 1, check whether the objective function value is 0 in the optimal table. Look at the optimal table. See the optimal table. This is the objective function values. These values must be 0 at the optimal table. If we get any values instead of 0, then the problem has no feasible solution. But in this case, we satisfy the condition. We got 0 values in the objective function. Now we can proceed further. Now we have to go for phase 2. In the phase 2, just write the values as it is from the optimal table but except the Cj values. For Cj values, we have to take the value from original problem. See, here we have x1, x2, x3, s1 and s2. Write as it is. x1, x2, x3, s1 and s2. Okay, but the Cj values are 0 in the optimal table, but here we have to write the original objective value. See the problem. Look at the problem. x1 value is 10, x2 value is 6, x3 value is 2, s1 value is 0 and s2 value is 0. So take all these values except artificial variable. So we have taken artificial variable in the phase 1, but for phase 2 we have to take all other values except artificial variable. For x1 10, x2 6, x3 2, for a1 a2 0 and 0. Basic variables are x2 and x1. x2 and x1. So x1 value is 10, so put 10 here. x2 value is 6, so 6. For all other values, see the previous table, enter the old value as it is. For x2 column 0, 1, 1 by 2, minus 3 by 4, minus 1 by 4, 5 by 4. Write as it is. 0, 1, 1 by 2, minus 3 by 4, minus 1 by 4, 5 by 4. For the next value also, write as it is. 1, 0, minus 1 by 2, 1 by 4, minus 1 by 4, 1 by 4. 1, 0, minus 1 by 2, 1 by 4, minus 1 by 4 and 1 by 4. Okay, now we have to find Zj values. For Zj value, 6 into 0, 0 plus 10 into 1, 10. The answer is 10. For x2, 6 into 1, 6 plus 10 into 0, 0. The answer is 6. Next one, 6 into 1 by 2 plus 10 into minus 1 by 2. The answer is minus 2. Next one, 6 into minus 3 by 4 plus 10 into 1 by 4. The answer is minus 2. Next one, 6 into minus 1 by 4 plus 10 into minus 1 by 4. The answer is minus 4. For solution, 6 into 5 by 4 plus 10 into 1 by 4. Answer is 10. Now, calculate Cj minus Zj value. Cj value is 10. 10 minus 10 is equal to 0. For x2, 6 minus 6 is equal to 0. Next one, 2 minus minus 2 is equal to 4. Next one, 0 minus minus 2 is equal to plus 2. Next, 0 minus minus 4 is equal to 4. Now check the optimality condition. The optimality condition is, for minimization problem, all the Cj minus Zj value must be greater than or equal to 0. So we have got all positive value. So now we have obtained optimality. So the optimal solution is 10. So the x1 value is 1 by 4, x2 value is 5 by 4, optimum z is equal to 10. Now we can check the answer by applying these values in the objective function. Look at the problem. The objective function is minimization z is equal to 10x1 plus 6x2 plus 2x3. Right here, minimization z is equal to 10x1 plus 6x2 plus 2x3. x1, x2 and x3. x1 value is 1 by 4. x2 value is 5 by 4. For x3, 0. And z optimal value is 10. The objective function is minimization z is equal to 10x1 plus 6x2 plus 2x3 must be 10. That is 10 into x1 value 1 by 4. So 1 by 4 plus 6 x2 value is 5 by 4 and plus 2 x3 value is 0 is equal to 10. 10 into 1 by 4, 10 by 4 plus 6 into 5 by 4, 30 by 4 plus 2 into 0, 0 is equal to 10. 10 by 4 plus 30 by 4 is equal to 40 by 4 plus 0 is equal to 10. 40 divided by 4 will get 10. 10 plus 0 is equal to 10. This is the way to cross checking the value with the objective function. Thank you. Hope you all understand this video.